All right, we're on. We're ready to rock and roll. Okay, now, what's next? Are we done with suspensions? Is there anything you want to add to suspensions before we begin with colloids? Colloids is big. In chemistry, colloidal chemistry is it's huge. No? Is that it for suspensions? Okay. How do you spell colloids? How do you spell that? C-O-L-L?
O-I-D.
Colloid. Colloidal. What is a colloid? First of all, let's start with how big is the particle? How big is the particle? It's small. Smaller than
1 micrometer.
Yeah, it's generally between is going to be between, right? Between 1 micrometer and 1 what? And what?
Macro.
No. Nanometer. Shall I tell you what that is? Nano, you've heard of nanotechnology? The word nano means billionth. 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 That's what the word nano means, billionth. Yes? Yes. Billionth. All right? So, it would be 10 to the negative ninth. So, that's what nano means. 10 to the negative ninth. Okay? Decimal point is there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? 1 billionth. Or 10 to the negative ninth. So, there are 1 billion. Is that right? There are 1 billion nanometers in 1 meter. Is it on the board? No? Let's see. You got to tap the screen though. Yeah, it's there. Not much, not barely, but anyway. So 1. Okay, can we turn the phones off, do you think? Would that be a good idea? One billion nanometers in 1 meter, so it's pretty small. What kind of combination of substances would be a solution? What size of the particles for a solution? A solution is smaller than 1 nanometer. Okay, do you remember that? Solution. Less than 1 nanometer. Yes? You understand that things clump together, get clumping. And we're going to talk, matter of fact, there's a section in the book on that. When you have a colloid that clumps. Did you get that far in your thinking? Anybody? Excuse me?
Are you really implying that we were thinking?
Yes, I was implying that you were thinking. Coagulation. When you think of something that coagulates, what's the first word that comes to your mind? Coagulation. What has to coagulate or you will die? Your blood has to coagulate. Yes? A coagulation can be a bad thing. If you have blood flow in your body and your blood all of a sudden coagulates, what happens? Yeah, you die of shock. Your blood stops flowing, right? All of a sudden you go, "Nee, boop." Okay, so, all right, colloid, size of particle between 1 nanometer and 1 meter. What else about a colloid? I'm making a wonderful, if I do say so myself, a wonderful video on chapter 15, and I'm going to do a lot of work on colloids, showing you examples of colloids, etc. So tell me what you know about colloids, from the book, from the external sources. Anybody? Masa, were you doing colloids? Who's doing colloids? Oh, you guys were. Okay, fair enough. What do we got?
Many colloids are cloudy or milky in appearance.
Cloudy or milky, okay. Cloudy, milky, okay.
Yeah, like
Can you have a clear colloid? Can a colloid be clear? Can a colloid be clear? The answer is yes. It can be clear. It can look very much like a solution, can't it? But what is affected? How do you know a colloid from a solution if they're both clear? I think this middle group, Jen, Mark, Diego, what is it? What's a test you can do on a colloid that will help you differentiate a colloid from a solution?
shine light.
You shine a flashlight through it. Okay, shine a light through mixture. And what happens? If it scatters, if the light scatters, what's it called? A colloid.
If it doesn't scatter, it's a solution.
It's a solution. What is it? What is the effect of a clear solution or a not so clear solution scattering light? In other words, the light particles will hit, a lot of light particles will hit
You can see the
particles of the mixture and scatter. What's it called?
It's called the Tyndall effect.
The Tyndall effect. How do you spell Tyndall?
T-Y-N-D-A.
T-Y.
N-D-A-L.
Double L.
Tyndall? Is it Tyndall effect or Tyndall effect?
Effect.
It's Tyndall effect. The Tyndall effect. Okay? So the Tyndall effect looks like this. Okay. Here I have 2 beakers. Okay? And I take a light and I shine light on it. And I shine light on this one too. Okay? Now, this one, the light goes right through. What is that? Is that a solution or a colloid? That's a solution. This one here is very obvious. What's that called? That's a colloid. The process by which that light is scattered is called the Tyndall effect. You get it? Just had to go do a side note on that. Anything else about the Tyndall effect? Jen, Massa?
It depends on the density of the colloid and the frequency of light.
So you can measure the Tyndall effect based on light densities, light scattering. You can actually measure that, can't you? Couldn't you measure that? So you can quantify, so the Tyndall effect can actually be quantified, can it? Mark?
Yes.
Yes. Okay. Very good. So what else about colloids? What else about colloids? Yes. Carry on. No, you didn't say anything? Anybody else? Emulsifiers? What do emulsifiers have to do with colloids? Nobody? We have a dropped football is really what this is. In American football, you'd say a dropped ball. They fumbled. Yes, are you fumbling? Yes. Ava.
So emulsions are part of colloids, and it's a mixture of two or more liquids that are normally.
So what's a emulsifier going to do?
It's essential for the formation of an emulsion and for maintaining the.
You put it in English. It sounded Greek. It sounded a little Greek. Yes, Simon.
Like in mayonnaise.
Mayonnaise.
Yeah, egg keeps the oil and water together.
Okay.
That's the
So mayonnaise is a colloid?
yes.
You're not sure. You know, colloidal chemistry is not easy. Let me show you what happens. Let's say we want to dissolve oil. Oh, it's time to go? All right, Saved by the Bell. Your group, I want to see you after class. Okay? All right. We're done. Colloids Part I. We got to do another on colloids, okay? Have a good one.